Okay, we are going to start. Good afternoon, good evening, good morning to whichever time zone you are in. Welcome to our AI in production webinar. It's the first of our quarterly webinars that we are going to be having either on this subject or in related topics. To those of you who are in Western Europe and experiencing heat wave, hopefully this webinar will distract you from the heat. I can guarantee you this, that there are no AI personas on this webinar. It's all real people. Before we get to anything, Ashwin, the next slide, please. Um, some housekeeping. We have got quite a few attendees, so in the interest of time, everyone will be muted. But we also want to make this interactive. So if you have any questions, raise a hand and we'll unmute you and then introduce yourself and fire away. And we are also going to have a Q&A at the end of this session. So feel free to chime in at whatever point or during the Q&A as well. To a quick round of introductions, I am Yadu Tekale. I lead the global sales for NEC. I'll come to that in a bit. Our key speaker is Ashwin Bilgi. He has worked in Microsoft, VMware, GitLab, Booking.com, and he's now in GitLab. But I will let him introduce himself a bit later. And then we also have Jawad Ansari, who is our VP Delivery based in Mumbai. Okay, we are part of NEC Corporation. It is a $25 billion company. You might have heard of it, headquartered in Japan with operations in about 50 countries, and we are just about everywhere, most notably in the public sector of various countries. My part of the universe of the NEC universe is on the right-hand box. That is NEC Software Solutions India. We are a product engineering services organization, and we deliver AI-led digital transformation to customers all over the world in different domains, right from 2% startups to listed companies, billion-dollar listed companies. We are about 1,500 people in three locations, one in Mumbai, one in Navi Mumbai, and the third location, Bangalore. And that's where our engineering team is. And from there, we service our clients all over the world. We are owned by NEC SWC UK, again, a software and solutions provider to the public sector in UK, and then they in turn are owned by NEC Corporation of Japan. So I think this slide should give you not only the ownership, but also what we do, particularly in my world of the universe. I will gloss over this very quickly. I just mentioned what we do. We are AI-led engineering in the digital transformation space. We also deliver some package software services around SAP and Salesforce. But yeah, this webinar is not about selling ourselves. It is just an introduction. What this webinar will also not do is tell you that if you do AI this way, this is how you lay off people. That's not it. This webinar is more from a practitioner's point of view, practitioners learning at an enterprise level and also at a personal project level. And with that, Ashwin, over to you. Sorry, quick list of our customers. Yeah, I am a salesperson. I should never forget this. Some of the names you are familiar with, particularly those in UK, Hargreaves Lansdowne, a very big platform, pensions platform provider. Economist, the one in the center, that's the magazine. Broadridge is a big listed fintech company. And again, I will not go through every name on that. But yeah, we work with customers, big and small, and in different domains all over the world. And again, Ashwin, over to you.
Hello, everyone. Thanks for joining this session, and thanks to Yadu, Jawad, Amita, and NEC Corporation for giving me a chance to share my learnings. A little bit about me. About 20 years in the industry, the first 15 as an engineer, individual contributor, the last 5 as an engineering manager. Currently, I'm working at GitLab. I'm responsible for the product and usage billing data infrastructure at GitLab. Before that, I was at Booking.com, where I helped them operate their private cloud infrastructure platform. If you have ever booked a hotel or a flight, that data landed in a database that was hosted by the platform operated by me. Before that, I was at Microsoft. I was the service co-owner for Azure Databricks. It's one of the largest services within Azure ecosystem, and also an SRE at uh, Microsoft for Outlook Mobile. So if you have used the Outlook email client on your Android or an iPhone, uh, the backend services were operated on infrastructure that that I looked after, and also database platforms at VMware. Uh, I'm not here to talk about any of my employers or like what I do at my employer. I had a very different uh, perspective to share here. So I have been an infrastructure engineer all my life, or at least the last 10, 15 years. Uh, my domain has been to take software that has been developed by developers and make sure it runs reliably. Uh, I've been skeptical of AI. I think it is like really cool, but can it really be operated reliably, right? So I was on parental leave for the last 4 months, until like a week ago. So during my parental leave, I had a lot of time while my baby slept on me. So I decided to look at, okay, let me check out what this AI thing is really about. My infrastructure background doesn't really go away. So rather than trying to be somebody I'm not, which is like an AI expert, I try to look at it from a infrastructure engineer's perspective, as in what does it take to run AI in production so that I'm not woken up at 3 a.m. in the morning when AI accidentally hallucinates a refund policy that doesn't exist or books you a hotel room that doesn't exist, right? So I tried to build a small AI agent framework. It's called Blender. You can check it out. Rather than just build it by myself, I also talked to some developers, some practitioners, some startups who are trying to build using AI. So this talk is about my experience building this and talking to those people. So not reflecting the views of my employer. This is a project that I did where I applied all my learnings throughout my career while I, did a hobby project during my parental leave. So the biggest question that I had was like, how do you go live with AI? Like, you hear about AI a lot. We have all seen AI generated images and videos, and we have used ChatGPT. But what does it really take to operationalize AI from a business perspective, right? So that was the question that I was seeking an answer to. Uh, let me take a typical example, right? This is a hotel booking form, right? Uh, you say where you want to go, and the dates and your preferences. One thing that stands out when you see a form like this, right? You've all seen a form like this. You can only select a date in this field. You can only check or uncheck the checkboxes. The drop down values can only have things that you allow to be listed in that drop down, right? So you are in control. You know exactly what you're going to get. The form will behave exactly the way you want it to. And this is how software has always worked, right? This is traditional software. This is every software that we have come to be very familiar with. So what's the what's the value, what's the advantage that AI can provide, right? With AI you can have a form like this, right? Rather than check boxes and select values from a drop down, you describe the perfect holiday, right? I want to travel first or third week. I'm not selecting a date. I'm giving my preference. I'm asking AI to make some judgment calls, right? And I'm also expressing my preferences. Like if there's a concert or a festival, try to book around that time. And I'm okay spending a little more money in order to have that experience. And I'd rather stay somewhere walkable with cafes and late night food, blah, blah, blah. You can't do this with your traditional hotel booking form. The one that we saw earlier was pretty straightforward, pretty boring, right? It doesn't really allow you to kind of customize the holiday to your preference. It's kind of on you, right? But with a form like this, you can actually describe the perfect holiday, right? And chances are a system that productionizes something like this will show you a location, show you a hotel that meets all this criteria. This is kind of the promise of the promise of AI, right? When everybody thinks they're going to build something using AI, this is the kind of magical experience that they all have in mind. This is the happy path. Like you book the most perfect holiday using this form. And a platform that offers something like this thinks that this is how the users are going to use their platform. Right? This is how a hotel booking website would think that customers would describe their holidays. But what if this is what your customers type in, right? The previous form described the the happy path. This is your worst fears come true, right? You're productionizing this newfangled thing called AI, right? Do you fully understand it, and can you protect your business from harmful actors who have a text box where they can type anything in, right? This is the fear that kind of stops a lot of people from productionizing AI. Like if when it works, it works. But when it doesn't work, the amount of things that can go wrong is kind of unbounded, right? Because it's just a text box. You can type in anything there. And this is kind of reflected in the industry trends as well. You pick any well researched article or on LinkedIn where people talk about AI adoption. The numbers are not very encouraging. You see numbers like 46% of projects are just stalled at proof of concept level, right? And they never progress beyond that. Only 6% of the companies actually trust AI in production, as in, for their core processes, something very critical to their business. 6% is a very low number given the hype and given the investments in AI, right? And despite all the tooling, all the observability, all the logging, all the monitoring, all the tools that are available to you, right? 89% are productionizing AI with all the tools. But despite that, one third of them think that the quality is not good enough. They can't go ahead because they are blocked on quality. So this is the sobering reality of AI. And my focus, like my curiosity was, okay, why is it, and what can we do to make this better, right? I don't claim to have all the answers. I'm still learning. I'm still figuring out. But these are some of the what I'm going to share are some mental models that I have formed. Based on whatever I've tried so far, the people that I've talked to so far. So that's what I'm going to share. So one learning that I had, right? Think of the predictableness, the predictability, and the production readiness of a software, right? Uh, the x-axis is the production readiness, and y-axis is like the predictability, right? When I write code, like traditional code, right, I write it on my laptop, right? It works, but it's the least stable because I know that there are a lot of things that need to still happen, right? And from my laptop, it goes through a CI/CD pipeline where tests run, integration tests, etc., checks, etc. And then there's a little more confidence in the software. And then somebody else looks at it, somebody does a code review, then there's more confidence in the software. Then you put it in pre-prod and finally in production. And traditional software, as it goes to production, right, you gain more and more and more confidence, right? That's what we see. That's the software development methodology we've all been familiar with. With AI, the stage that is we are at right now, we still do all these things. We still go through CI/CD, we still go through code review, we still put it in pre-production. But despite that, right, every time you go ahead, what happens is you discover more and more and more ways in which AI can fail, right? When I'm trying it on my laptop, I want AI to work and I just enter a bunch of prompts and it works. And once I'm happy, I send it to my teammate. They do a they enter a prompt that I've never thought of. It breaks, and then we fix it a little more. Then we put it just before production. We test it with all the prompts that we have seen so far. Even then we are not very confident because at the end in production it's still a text box. People can still enter anything there. You don't know what people might enter where it can break, right? So despite us still developing it the way software has always been developed, the unpredictableness, right, like the fear that it may break only gets worse as we go closer and closer to production, because we are just made aware of more and more failure modes. And that is kind of a common thread that I've observed on almost everybody who I talk to, right? So why is this, right? In what This was one realization that I had, that the tools that we use, the monitoring tools, the observability tools, right, the alerting, logging tools, right, you might have heard of people talking about stability in terms of uh, number of nines, like six nines of availability or stable, 6 nines of reliability is considered like really good, really aspirational. That is 32 minutes of downtime, right? That's because these tools deal with aggregates and percentiles and long tail latencies, statistical methods, right? And this is the kind of software that people also use to monitor AI. But the reality of AI is that all it takes is one failure for it to do outsized damage to your company, right? Like a hotel policy, a refund policy that doesn't exist, or it recommends you a wrong medicine. All it takes is one for your company to have disproportionate amount of harm, right? So you might see, it. What I've observed is it's very hard to troubleshoot and identify failures using the traditional tools, purely because they are built for a world where software gets more and more predictable as it goes to production. Whereas with AI, you are searching for a needle in a haystack, and needles can occur anytime, right? So this is one gap that I observed, that a lot of our observability and monitoring tools that deal with aggregates and percentiles may not be the best fit for troubleshooting AI, because simply because the failure modes are too many, right? It's again one text box, you can enter anything there. How do you even start? And here's the other interesting thing. LLMs are fundamentally probabilistic, right? Let's say you have an LLM that returns the right answers 90% of the time. But the way LLM loops work, like, you ask a question, it returns an answer, and then you type in under prompt, it gets prompt engineered, the entire context gets sent to the LLM model, and then the response, so on and so forth. At this point, it's math, right? Something that works 90% of the time when you make one call if you make a series of calls, by definition, right, like 0.9 raised to 6 is around zero point 0.5. Like you are, within 6 calls, you've gotten to a coin toss level of probability, right? And this is why, despite all the hype, despite everything that, the AI model creators like OpenAI or Anthropic or all the big tech companies, and even a lot of enterprises, a lot of startups, they really want AI to work. It has seen a tremendous amount of investments. There's a lot of enthusiasm, a lot of engineering leaders and industry leaders want this to work, but we kind of have arrived at a consensus that it kind of works well for coding agents. Everything else, all the other areas, we are still figuring it out, right? Why does it work so well for coding agents? It's because code is something machines can understand. It's formal specification of behavior, right? And there are deterministic guardrails, like you have compilers. A code that AI wrote, if it doesn't compile, the AI can run the compiler itself and figure out what broke and fix it immediately, right? And there are unit tests and there are integration tests. So basically the feedback loop is like really, really fast. So you can still kind of, you are kind of like driving a car where you are navigating the steering wheels, constantly, right? And there's an expert human in the loop, the programmer who is actually driving the AI, who wants it to work and who is kind of responsible for the outcome, the software, the quality of the software, and the how well it works. That is still ascribed to the human, even if the human used AI to write it, right? So this is this is why coding agents still work, because you know specific conditions that allow for success. But then, does it really work? Like even with coding agents, right? What you are, what's happening is you are amortizing the decisions over a long period of time. Like you are constantly asking AI to write something, and you're saying yes, proceed, proceed, yes, 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 and over a period of time, you're kind of letting AI take over, right? They accept the approximations, and those approximations kind of compound over time. At some point, you've just surrendered to AI, you're just letting it write the code. It kind of sort of works. The observable surface kind of seems to do what you thought it was supposed to do. The industry calls it vibe coding, right? But what's kind of happening is, it's a very interesting term called cognitive surrender. I says that you Google it, right? It's where you kind of give in to you kind of outsource the judgment to AI and kind of surrender to whatever output it generates. So even with coding agents, there hasn't been like outsized efficiency gains or lot of high quality software that is being produced because there is now AI, right? Far too less evidence for us to make that claim. And this also provides a hint as to why it doesn't work as well for customers, right? If you're building AI where your customer is interacting directly with an AI, if you build the text box, right, the customer isn't interested, or rather customer isn't as interested in prompting AI so well that it works, right? A customer is not going to prompt as well as an engineer would do to make it work. They are the customer, they are expecting a service, right? They are not there to own the outcome. And especially like in India, for example, a lot of digital connectivity is through mobile phones, right? And things like WhatsApp and instant messaging. The problem gets even more magnified in such scenarios because a very short WhatsApp or a tweet like prompt is not going to yield as great results, right? End user inputs are always going to be lossy compared to what a developer would type, especially on mobile, right? And that's how a lot of users consume digital services. And one of the reasons why, AI is really hard, right? And here is one more observation that I had. People claim that AI works. You might have heard that some company outsourced all their customer support to AI. Like, they fired all the human customer support and now AI does all the customer support and they saved so much money. And, that's a victory for that company. But, uh, you know, uh, one caveat there that a lot of people miss is a lot of a lot of users are desensitized to bad customer experience, right? Like if you are stuck on a phone waiting for a long time, or like you simply didn't get the desired result and you just gave up pursuing it, right? You're already desensitized. Or another example, if somebody built an AI recruitment software, right? If you have ever been in the job market, if you have tried to hunt for a job, think about the amount of job applications you have sent out, or apply amount of number of jobs that you have applied to, and number of genuine responses that you got, right? So you are already desensitized to being ghosted by recruiters or not hearing back, or getting an automated mail. An AI recruitment platform could probably be declared as a success because the bar is already low, right? The user, the end consumers are already desensitized, right? So it's uh, whenever you hear about AI successes, it also helps to pay attention to who was the real customer there, who really got the benefit of AI being deployed, right? One rubric, one mental model I had developed is the human whose judgment determines whether an AI interaction succeeded. That is the real customer for AI, right? Let's say if you interacted with an AI customer support bot, but you had no chance to leave feedback whether you got good support or not, but some leader of the uh, product or the service you are consuming decided that you had a successful interaction, then that leader is the real AI customer, not you, right? Because it isn't always the end user who is determining the determining whether the interaction succeeded, because the end user in this case might be the corporate leader who made the decision to replace customer support with AI, right? So yeah, like I said, I approach this from a infrastructure engineer's perspective, somebody who doesn't want to be woken up at 3 a.m. to troubleshoot a failure, right? So these are the failure modes that I observed, right? So if I were to run an AI application, if I were to productionize something in AI, what would I really do? Like, this is what needs to be, AI, we need to go live with AI, we need to productionize it. How do I really, what do I really do? Right? The infrastructure engineer in me will treat AI as an extremely unreliable external service. That's what I would do, right? That's where I would start. What does this mean? One, separate your deterministic code from the non-deterministic code. Like isolate the highly unreliable, highly unpredictable system, right? Keep the rest of your system as is, keep the unpredictable system separately, right? If you mix, like for example, you already had a web app and you made an AI LLM call inside that web app, and then very soon you have prompts and you have a bunch of context engineering, prompt engineering things scattered all over your code base. Your database has a lot of data that is generated by AI, or kind of led to be generated via AI. And very soon, it's you are not able to separate the two, and your actual business gets affected. Like the business that you already had without AI, that starts being affected, right? So, principle number one, isolate them, keep them separate, right? Principle number two, capture all state, right? As in, like for example, if you are in India, you have booked, let's say, an IRCT, your Tatkal ticket on IRCTC, right? Uh, uh, I've not done that recently, but if based on my past experience, I would try to book a Tatkal ticket if I'm traveling tomorrow, and the ticket window opens at like 9 a.m. and I'm logging in. Everybody else in India is also logging in. The system is kind of shaky. What do I do? I make sure that I note down the transaction ID. I note down whether uh, 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 the credit card thing, the credit card provider sent me an SMS. I check my bank statements, right? Basically, I'm accumulating as much state, as much proof around the conditions of how I made the AI call, right? So that I can verify whether it actually worked as expected. So let me give a little more concrete example, right? Think of a letter. Okay. You're sending a letter from Delhi to Chennai. It's a very important letter. It doesn't go directly from Delhi to Chennai, it goes to multiple offices in between. So, an office in Delhi sends the letter, right? It sends it to Mumbai. The office in Mumbai receives the letter, modifies it a little bit, puts a stamp or a seal or something, forwards it again to another office, this time in Hyderabad. They receive the letter. They again edit, add another seal or write something more. Then they send it to Bangalore. Again, more seals, more editing, like more appending, and then finally they send it to Chennai. Right? Like I said, it's a very important letter. There is a workflow, right? It goes through like three offices before finally reaching Chennai. Right? Think of this as an example. Now, let's say the letter got lost somewhere in between, right? Uh, let's say the letter got lost somewhere in transit from Delhi to Chennai. How do you find out where the letter was lost, right? The guy in Chennai, the office in Chennai says, "Hey, we never received a letter. We were expecting a letter. We never received it. What happened?" So first I said, "Can you really check? Can you check your folders? Can you check your mailbox? Are you absolutely sure that you didn't get the letter?" Said, "Yeah, no, we didn't get the letter, right?" So then I go to Bangalore and I say, "Hey, the Chennai folks didn't get the letter. Did you send it to them?" Bangalore says, "No, I never got any letter either. So there was nothing for me to send. So I never sent anything." Okay. Then I go to Hyderabad. "Hey, did you guys not send a letter to Bangalore?" They are saying that they never received it, right? Hyderabad guy said, "What do you mean? Like, I sent a letter. I definitely did send it. Here is a receipt. Like, I sent the letter. Looks like the Bangalore folks didn't receive it." So now you know the letter got lost between Hyderabad and Bangalore. So now you are investigating what really happened between Hyderabad and Bangalore, so that you find out why the letter got lost, so that you can that doesn't happen in the future, right? So that's how you investigate this failure, which is nice. But now the person in Chennai still needs the letter. There's nothing you can do. You have to go back all the way to Delhi, ask them to send the letter again, and it will go to Bombay, it will go to Hyderabad. This time, the Hyderabad folks make it, are really careful. They send it to Bangalore, Bangalore send it to Chennai, and then finally they have the letter, right? But what happened is we were able to narrow it down, but we had to go again all at the beginning to resend the letter so that it actually gets delivered correctly, right? But what if we had tweaked this process a little more, right? What if instead of simply sending the letter, every office, right? What they do is they make a copy of the letter that they got, and they make a copy of the letter that they sent. So Delhi is the first person who sends the letter. They make a copy. It goes to Bombay. Bombay makes a copy of the letter that they just got, and then they edit it, modify it. They make a second copy, and then Hyderabad makes a copy of the request, makes a copy of the response. Say Bangalore also does the same thing, makes a copy of the request, makes a copy of those. So now, if the letter got lost between Hyderabad and Bangalore, you go to Hyderabad, hey, Bangalore folks didn't get a letter. Said, okay, cool. I have a copy. Let me resend the copy. But you see what happened this time. You don't have to go all the way to Delhi to resend the letter. You could just resume from where it failed, right? So this is what I mean by capture all the state. So just by capturing everything that happened, you're able to retry and you're able to resume from where it failed, right? I just used a very elaborate, very simplistic example to describe a fairly fundamental concept in computer science. Is called an immutable log, right? You see it in queues like RabbitMQ or Kafka or SQS. It's a very common architectural pattern called event sourcing. If you've built like sufficiently complex microservices based system, you've already done this, right? The difference is it used to be an optional good to have technique in the world where software was very deterministic, but with AI it kind of becomes table stakes. It's still the same old technique. As an infrastructure engineer, I would insist that we do this, whereas earlier it was still manageable, right? So that's the second principle. Capture all state so that if it fails somewhere in between, you know exactly why it failed. And also you can retry and branch off and attempt something differently. This is all the more important in the world of AI because AI is fundamentally non-deterministic. The branching logic is kind of determined on the fly, unlike your traditional software where it is like very predictable, right? So this is the second principle that I landed on. And here is one more important thing, right? Design failure first. What do I mean by this? Is like if you are building a hotel booking system using AI, make sure you have the refund system and a troubleshooting system as well. Don't go live with only the hotel booking text box. Go live with the refund mechanism first. Once you have that in place, once you've proven that to work, then productionize the the ticket booking text box, right? So when it comes to AI, the you know I'm make like remember my original hypothesis that treat it as a very unreliable software, right? So for that software to go live in production, the compensating transactions, the things that you do to make it right by the customer, the things that you do to make sure your company does the right thing, that is the real product, right? The text box comes after. What should be there before is the way to address the failure. And for you to address the failure, you need to know that a failure happened in the first place, right? And here is another principle: build using protocols, right? I'll explain what this means. Like we are all familiar with protocols, right? You probably use a Chrome browser to browse the internet, but you could also use Firefox, or you could use Opera, or you could use Edge, or any other browser. Why? Because HTTP is a protocol, REST is a protocol, SQL is a protocol, right? What protocols let you do is it lets you swap in and swap out the implementation details, right? You can change one part of the system, keeping all the other parts standardized, and that lets you benchmark things. Like, you tested using one version of the software, or one model, or one platform, one AI provider, and you swapped it out with a different AI provider, right? You have test plans, you have acceptance criteria, you have regression suits. The funny part here is we have been doing this for ages, right? We have been doing QA for ages. We have been testing before software lands in production for ages. Why should we treat AI any differently, especially when it is so, it doesn't always do what you want to do, right? And this is why you need to uh, bet on protocols, on standards, because it allows you to swap the most critical part of this system, which is the most unreliable part, which is the AI LLM model, right? Let's say today Opus is $75 per million tokens. Tomorrow it's $300, right? You still need to run the business. You need to see if a different, cheaper model is still able to do the same things that you're kind of relied Opus to do, right? So you have migrated databases, you have switched cloud providers, right? Is the same concept. Be able to swap in and swap out these different models, so that your evaluation infrastructure, your ability to A/B test different systems, that is your competitive advantage. That is what will allow you to actually productionize AI systems. If you look at companies who have been able to actually productionize AI, if you look at, Google does it, or Stripe does it, or somebody else does it, right? Why? Because they have the pedigree of doing great engineering even before AI. AI just made it table stakes, right? But if your engineering techniques, engineering culture has not kept up with the times, and now you're trying to do AI, you're probably going to have a hard time. So, coming back to the text box, right? We talked about the risks. We talked about the, how unreliable AI is. We talked about all of that, right? But I still want this. I still want to be able to book a holiday like this, right? This is amazing. This is great, right? This is what, this is software that we have always dreamt of, right? AI really is the coolest technology that we have ever, I have ever seen in my lifetime, right? The text box is worth building. It just takes a lot of old-fashioned engineering. It, don't discount what it takes to go live. Don't discount the discipline, the rigor that is needed to productionize AI, because that is what it takes. It's worth building good software with great user experiences. It just is something that requires a lot of discipline. That was my presentation. I see one question. Shall I read it out?
Yeah, go ahead, Ashwin.
Alfonso raised a question. I find the principle of sourcing all events and keeping immutable log especially hard, given that LLM vendors, OpenAI, Anthropic, etc., are more and more opaque. Even an open weights model, if it's a reasoning model, there are internal chain of thought tokens that are not so visible. Have you hit that imitation that felt frustrated at what little you can get as a trace? Yeah, this is exactly the challenge, right? A lot of the model providers, they kind of try to capture the value in the latent space, right? What we can control is the calls we make and what comes back in return, right? So we can be in control of our deterministic system as much as possible, so that you treat the vendors for what they are supposed to provide, the SLA that you're supposed to, they are supposed to guarantee, right? If your software boundaries are clear and you are capturing the state, then it is really up to the LLM provider, the model, to provide the service that you expect it to provide. And that's your evaluation criteria. I hope I answered your question, Alfonso. Please feel free to chime in. Thanks.
Yeah. Are there any other questions from anyone at this time?
A question from me, Arjun. Sorry, Ashwin, is you said that this you are introducing a lot of uncertainty by introducing AI.
Yeah.
So, where with vibe coding being the latest hype cycle, how are you able to introduce vibe coding at scale?
Uh,
So I can totally get that vibe coding. It's good for small engineering teams or even a solo developer, etc. All the stuff that works. But you have got a 1,000-person engineering team. What
yeah.
can a 1,000, 2,000, 3,000, 10,000-person engineering team? How can they use vibe coding in a disciplined manner?
Well, be clear on the outcomes, right? Uh, End of the day, the software is supposed to produce outcomes. It is supposed to do what it is supposed to do. Have clarity on what the software is supposed to behave, right? How the software is supposed to behave. And as long as you can evaluate the behavior of software against your expectations, does it really matter if I vibe coded it or I wrote it with my hand or something else? It doesn't, right? It's supposed to do what it is supposed to do, right? The thing with software is, yeah, a lot of tech debt and a lot of bad design choices. They don't reveal themselves immediately. They only reveal over time. But that has always been the case even before AI, right? AI just made it possible to accelerate it much faster, and hopefully, we can evaluate outcomes faster. So you can also use AI in a red teaming manner, right? Like you can also use AI to generate a lot of hypothetical scenarios and test the software, right, that you wrote. So that's one of the techniques that I've seen. You basically pit AI models against each other. You have a reviewer agent and you have a coding agent and you have an observability agent. So that's one of the techniques. Uh, to me, like as in right now, I'm an engineering manager. Uh, I at my day job, I don't, I don't really care how they wrote the code. I care that it does what it is supposed to do, right? And as long as it meets that criteria, the implementation detail doesn't matter. So I don't have anything against vibe coding. It still needs to do what it's supposed to do. So that's that has always been the case. I hope I answered your question, Yadu.
Yep, thanks. I think there's one more question for you, Ashwin.
Satish is asking how to overcome LLM hallucination. You don't. You you use it knowing that it hallucinates sometimes, and you build a system that is resilient despite that. So, like I said in my slide here, uh, I can't find that slide, right? Your compensating transaction and your ability to react when it fails, that is your real product. LLMs are always going to hallucinate. If you can't prevent a hallucination from doing real damage, then it should not be in production. I hope I answered your question, Satish.
So, one more question from me, Ashwin, is from your experience as an engineering manager, what best practices have you seen to encourage engineers to take up AI in their day jobs? So, I'll give. So, we are, like I mentioned in our introduction, uh, we are a services provider, and we work
Mhm.
with numerous customers all over the world. So,
Yeah,
we have seen the extreme. So, we have got the one extreme is where companies have bought tokens outright, and they even maintain leaderboards of which developer is using what. Yeah, so you see the subtle pressure exerted on the engineers to use out the tokens, and then on the
yeah,
other you have got companies who train engineers on all this stuff. So what
yeah.
in your opinion has worked well, what has not worked well?
Yeah, I don't believe in token maxing or token leaderboards. That's Goodhart's law in action, right? If all you're measuring is token usage, then all you get is a lot of token usage. Like measure what matters, measure productivity gains, measure b- impact, positive impact to the company bottom line, measure customer satisfaction. Start from there, right? And as always with any new software, any new technique, start small. Don't try to go big on day one. Like, what's the smallest productivity gain you can get? What is the smallest boring but necessary job you can automate, where you can still afford to observe failures so that you can correct it later. So use that as the training ground to get better at addressing finding, detecting, addressing AI failures. Develop that muscle, and only then graduate to bigger and bigger problems. AI is amazing. Like, if amazing if you for educating yourself. Like, as in, I learned, I wrote my pet project during my parental leave in Rust. I had not written a single line of Rust in my career before that, but I was able to do that. I was able to teach myself Rust using AI. It's amazing as a tool to learn. Uh, the moment you start producing outcomes and start owning the outcomes, that's when it becomes challenging. So my suggestion is always would always be, start with the smallest possible thing that you think you can afford, right? Get really good at it, and only then graduate to a slightly higher, more complex problem. It's like going to a gym, right? Like, if I'm going to the gym for the first time, I don't try to lift 200 kg on day one. I start with an empty barbell, slowly add more and more weights, and only then earn the right to do the heavy lifting. It's the same here.
And again, from a enterprise level of engineering teams, large scale engineering teams, how do you measure productivity and velocity? I mean, velocity is probably easier to measure, but how do you measure productivity with AI deployment?
Uh, it uh, the productivity means different for different people, and it's always very easy to abuse. The industry standards are DORA and scope metrics. These are, there is uh, uh, Dr. Fosgen, and there are these techniques called DORA and scope, which are like fairly fairly uh, well known, fairly adopted, adopted across the industry. I would still start with that, right? Like, productivity is hard to measure objectively. It's not something that you can easily quantify. But there are techniques, there are ways to measure developer productivity. I would still start with that. The fact that I'm doing this using AI, or the fact that AI is in the mix, or it is being hyped right now, doesn't change what rigor means, right? Like, Dora and scope are like fairly rigorous. I would still lead with that. I would still lean back on established best practices on measuring outcomes and measuring productivity, and see how much AI actually helped, rather than try to invent something that purely because AI exists. Like, end of the day, company bottom line is the company bottom line. Our customer satisfaction is paramount. So always have to optimize for that, and measuring that has, you know, is already a solved problem.
Alfonso has got one more question for you, Ashwin.
Yeah. Do you think that as more and more engineers use AI, we will settle on a very boring pattern and innovation will stagnate somewhat because we rely on patterns in the corpus? Well, I think that as we get good at solving what are problems today, we will find newer problems to solve. We'll find better quality problems to solve. So I don't think it will be boring, because, like, the moment I figure out how to use AI very well for, in a coding agent, right? I now want to do this where I'm not writing code but doing something else. Like if I'm doing a code review, or if I'm monitoring a production environment or something else, right? So y- y- yeah, I don't think it will be boring or whether it will stagnate. We will just graduate to better quality, more good to have problems. That's what I think. I hope you answered your question, Alfonso. Uh, Satish is asking, when should you train, fine tune an LLM, or use agentic AI? Uh, Fine tuning in the LLM requires data and requires the infrastructure. If you have really run into limits of established boring techniques, then you try to find the bigger solution, right? Find not many companies, many customers can afford to do fine tuning, simply because the data doesn't exist. Even if the data exists, cleaning it, or making it consumable in a manner that you can use to fine tune a model, that is hard. The infrastructure is expensive. It's really, uh, to answer your question, when should you fine tune? When the business outcome is worth it. That's how I would put it. Alfonso, so I came up with the question due to your experience with Rust. If AIs can write average Python, maybe Rust wouldn't have been invented. I didn't get your question, Alfonso. What do you mean? They are two different languages. Python is interpreted, Rust is compiled. They both have their own strengths and failure modes. I don't think if Python was good enough, you wouldn't need Rust. I don't think I agree with that. maybe you can elaborate on your question.
Hi,
Maybe I
hi,
didn't.
Ashwin. Can you hear me?
Yeah, I can.
Okay. So no, it's about my earlier question. So the point is, if we, I don't know, if we all start to ask similar questions to the AI, and there's a common use pattern or an architecture or a structure that the AI will start regurgitating in Python, let's say, for the sake of
Mhm.
argument,
Okay.
then because I can get away with that average or maybe above average Python structure, then maybe that there is no need to develop maybe a different language because the AI can do it just well enough. I know that Rust tackles a very different kind of problem other than Python, but
Mhm.
it always made me think with AIs, maybe we will see new language come less often or new frameworks come less often because AIs get very adept at writing in the languages that are now in the corpuses. So maybe there's no need or less curiosity to start and say, okay, I'm going to start a framework or from scratch or something like that, or a language
I
from
Yeah,
scratch.
I see. I get your question now. I think I disagree because you, like the need for compute and need for software patterns and need for techniques, they kind of expand to fill in whatever gaps, whatever is left on the table by things that are already being done well, right? Like if AI already does everything that we currently do well, we will then think of the next problem that it can't do, right? So there are always going to be problems that can be solved using software. So as long as real problems exist, software will exist, and we'll find new ways to tackle those problems. So I don't think it will be static. It might seem so right now, but you will definitely, I think you'll definitely move to a higher level of abstraction where you're solving problems at a larger scale. You kind of already see this happening, right? Once you are able to get AI to reliably do one thing, you kind of try to tackle the next bigger thing that it doesn't do currently. So there will always be innovation. I don't think we'll be static. I disagree with the premise of your question.
Okay,
That,
thank you.
yeah. Uh,
Ashwin, there is a question from Yogesh. I'll allow him to talk if you want.
yeah, I don't see it. Is it in the?
Yeah,
Oh, yeah,
I'll
yeah, yeah,
just,
yeah. I can see it. I can
I
see it.
have, he can talk. Yogesh, you can talk if you want to ask the question.
I can see the question. I'll read it out
Okay,
loud.
okay.
Application may rely on multiple LLMs and providers as a general purpose LLM may not satisfy all the requirements. Does it worth to invest efforts in minimizing vendors, or is it okay to have as many vendors to fulfill the requirements? Bet on protocols, bet on standards. As long as you're programming against a standard, you can always have one provider or 10 or as many as you can. It doesn't matter. The moment you write code that only works with one vendor, that's when you are kind of betting on that that's where you are kind of taking a risk of that vendor always being able to do what you want it to do, be it in terms of model capability, price, reliability, etc. Bet on standards, and as long as you bet on standards, and as long as you can swap in, swap out model providers and benchmark and test different providers, you are at an advantage, right? It's the moment the great the nicest thing about LLMs, if I say so, is they're all stateless, right? An LLM, when you make an LLM call, it doesn't it just returns the probabilistic text output for that particular call. It doesn't remember that you made this call. This next call you make, right, requires prompt engineering and the agent harness to pass on the conversation history. So the traditional challenge with data gravity doesn't apply here. Like let's say, for example, let's say you had a Postgres database on AWS. Now you want to move to Azure. You want to move to Postgres database in Azure. You still have a data gravity problem because the data can only move at the speed of light. So it still takes time to move the data from Azure to AWS, and there's a downtime in between, right? With LLMs, you don't have that problem, at least not yet, right? They don't remember what you how you invoked them. It's all the harness engineering and the context engineering that goes around. That's where the lock-in comes in. So as long as you bet on protocols and bet on standards, you can avoid lock-in, and you are kind of only reliant on the model capabilities. You don't really need you don't really have to worry about vendor lock-in. So that's why I said depend on depend on standards as much as possible. So build on protocols. For example, if you go to Anthropic has its own LLM protocol, API protocol. OpenAI has a protocol, but OpenAI's protocol is standardized across all the providers. Like if you go to OpenRouter and use DeepSeek, you can still use DeepSeek using OpenAI protocol. You can still use ZAI or Minimax or GLM using OpenAI protocol. So that actually allows you to swap the models. You are not really vendor locked in. But if you are using Anthropic, as far as I know, many model providers don't provide an Anthropic compatible API, which means you can only use Anthropic. Like if you develop an application, it can only use that one API provider. So that's what I meant. As long as the protocols are standard, you can avoid vendor lock-in. I hope I answered your question, Yogesh.
Yeah, sure. Thank you.
Deepak is asking, hi, with extensive logging needed for each step you mentioned for each request to LLM, how do you analyze these logs and failures and check for quality of responses? Uh, so here is one thing, right? Like, hopefully you are not productionizing AI systems that are, like thousands or like hundreds of thousands or tens of thousands of transactions per second, right on day zero, right? You're going to start small. So which means whatever log analysis or whatever state analysis techniques you implement, it doesn't have to be large scale on day zero. It just needs to work for the kind of traffic that you can expect on day zero. So, as you get good at it, as your LLM actually does what it is supposed to do, as it organically generates more traffic, your tool can grow. And at that time, you can choose which tool to really use, right? Like if you have a high cardinality problem, you might use like a Cassandra or like something else, like, or if you have really structured data, you would use something else. So yeah, you can pick and choose the techniques as you grow. You don't need to solve this problem on day zero. Does that make sense, Deepak? Did I answer your question?
Yeah. Thanks so much. So after we have subsequent increasing traffic and all that we need to know about Cassandra, is it a case that we can use LLM itself, some other LLM itself to analyze those logs?
Well, yeah, so you are, you are using a second tool to analyze the logs. You have some criteria for how well that tool is supposed to work. evaluate that tool using that criteria. Whether it uses AI or not doesn't really matter. So you can keep one tool static and evaluate the other one, and you can keep the second one static and evaluate the first one. So you can use them against each other in in adversarial manner. But the point is, as long as you have very good clarity on what a tool is supposed to do, and you benchmark it, evaluate it, A/B test it like any production grade system, it's just another AI based tool. The same principles apply. So I don't really make a distinction based on whether you are using AI to serve customers or whether you are using AI to evaluate AI that serves customers. They are both tools, they both have different purposes, but evaluation criteria is what is this tool supposed to do well and how well does it do it. Did that make sense?
Yes. Thank you.
Right. Anyone has any other questions? Okay, Ashwin, I think we'll call it a day. Many thanks for your time. Many thanks for all the participants.